is about the spinach project, which I use RNA aptamer that combines a small molecule called DHBI to induce the fluorescence.
Move over here, sorry.
To induce the fluorescence of this RNA small molecule complex. And so in a previous science paper, the people show that this binding complex has similar fluorescence as EGFP, and when people induce this RNA into an E. coli cell, if the RNA is expressed at a very high copy number abundance, it can emit very nice fluorescence signal. So what I'm now doing is that as this single repeat RNA small molecule binding complex has relatively low fluorescence, it's not useful for imaging regular mRNA or other RNAs or tracking them inside the cell. So what I'm now doing is to engineer the RNA with multiple repeats, this RNA aptamer in parallel, and then try to enhance the signal on the single RNA, and finally maybe get a single molecule resolution of the RNA imaging. So what we have discovered now is that this imaging method is has some advantages. For example, compared with previous RNA imaging method, live cell RNA imaging method. So this RNA aptamer does not interfere with the RNA degradation. Based on what we demonstrated on the imaging experiments and the qPCR experiments. But for further study, which we want to get the single molecule resolution, so I later realized that it cannot be achieved without Quyon's work. So he was doing experiments on the characterization of this physics and chemistry of this RNA aptamer. Yeah. So now Quyon can introduce how it works.
It's really not my method, but anyway, first of all, I really like to figure out why this RNA aptamer emit the fluorescence. So let's imagine I'm the RNA aptamer. Jichuan is a small molecule. In the beginning, this guy doesn't have any fluorescence. But
non-fluorescent.
Non-fluorescent. I'm completely well folded by magnesium and well buffer system. Now,
and once we bind together,
fine. This guy starts to emit the fluorescence. But the problem is when you illuminate the light, it seems like it dissociates very fast. Within 100 millisecond time scale. But the funny thing is after a few seconds, and then they rebind again, and they emit the light and dissociate again, something like that. But I'm not pretty sure this is really dissociation, or this guy completely go to change another conformer. So we don't know exactly. So I'm wondering, can you explain with another photophysical method? This is a really dissociation or not? But pretty much we got a lot of evidence. This is a photo-induced dissociation and rebinding process. So we can, if we control the power and also we can control the concentration, we can completely manipulate binding and unbinding kinetics with RNA aptamer. Probably we can use that property with live cell RNA resolution imaging.
And one phenomenon that Quyon found is that when you use the laser to shine and excite this RNA complex, so it get like the fluorescence get decay in very fast time period, about 100 milliseconds. But after you like remove the light, wait for several seconds, and then excite it again, so the fluorescence signal got like almost 100% recovery. So this is very useful for the live cell imaging, because for very like low copy number RNA in the cell, when you first try to excite it with like relatively strong excitation, so all the signal you are looking for get messed up with the autofluorescence of the cell itself. But if you use this like excite and then remove light and then excite it again. So we can first try to bleach all the fluorescence of the cell by a low intensity laser excitation for several seconds, and then wait for several seconds without the light and then shine again. So the autofluorescence will never come back again, but for the spinach signal, it will get fully recovered, and you can see the RNA signal only in the cell.
I think
So that's what a very good application for my research.
Next, our collaboration, we'd like to do, this kind of interesting phenomenon is very quite interesting, but still we'd like to do, we are stick to a very long time, let's say, for several seconds. But in that case, we should optimize the RNA sequence, or we should look into the small molecule structure in more detail. So what's going on? So probably in that case, in that direction, we can control a lot of interesting stuff. Probably within a few months.
Yeah.